Hi, hello, welcome to Max Dini. Last video we discussed how to form a differential equation. What is differential equation and how to form a differential equation. Now we want to solve a differential equation. Now we want to discuss some method to solve differential equation. So for equations of first order and first degree equation, we have different types of equation, first order and first degree, and which are equations where variables are separable and homogeneous equation, and third one is linear equations and also exact equations. So there are different methods to solve these types of equation which is under the category equation of first order and first degree. So first we discuss variable separable method. So these are the equations where we can separate variables. That means we can separate x and y if x and y are variables. That means which is of the form x dx equal to y dy. That means a function of x and dx and a function of y and dy. So we separate x and y. So x is in this side and y is in this side. Now we integrate f of x dx and f of y dy. So this gives the integral of f of x, and suppose this is capital F of x, and this gives the integral of f of y. Suppose this is capital F of y or some g of y plus the constant. So this gives the solution. So if given differential equation we can separate variables, then we can use this method, variable separable method. For example, given a differential equation dy by dx is equal to e raised to 3x minus 2y plus x square e raised to minus 2y. Now we can write this as e raised to 3x minus 2y is e raised to 3x into e raised to minus 2y. That is e raised to x plus y is e raised to x into e raised to y. Now plus x square e raised to minus 2y. Now e raised to minus 2y is common, so let's take it outside. This is e raised to 3x plus x square. So dy by dx is equal to this one. Now we can separate variables x and y. So this is all term with the x. So and this is the only term containing y. So let's take this in this side. That means e raised to minus 2y. 1 by e raised to minus 2y dy. This is dy by dx. So 1 by e raised to minus 2y dy equal to e raised to 3x plus x square dx. Take all x terms together and all y terms together. So this is e raised to 2y. 1 by e raised to minus 2y means e raised to 2y dy, which is e raised to 3x plus x square dx. Now we can integrate both sides. Integrate both sides. E raised to 2y dy integral is e raised to 2y divided by 2, this constant 2, equal to e raised to 3x with respect to x is e raised to 3x by 3 plus x square x cube by 3 plus integration constant is c. So this is integral. Now we can take 2 this side and 3 this side. So we can simplify as 3 into e raised to 2y. So let it be c by 3. This is a constant, so we can take c by 3 as constant. So take 3 common here and 2 e raised to 3x plus 2 x cube plus 2c by 3. So this is the final form, or we can take 2c by 3 as constant c dash. So 3 raised to 2y is equal to 2 into e raised to 3x. We can write as 3 raised to 2y equal to 2 into e raised to 3x plus x cube plus a constant c dash. So this is the final answer. Now let's solve this equation. Dy by dx is equal to 4x plus y plus 1 whole square. So this is 4x plus y plus 1 whole square, little bit complicated. So put t is equal to 4x plus y plus 1. Now what is dt by dx? Let's differentiate both sides with respect to x. So 4x derivative is 4 with respect to x plus y derivative is dy by dx with respect to x plus 1 is constant, so 0. So we get dy by dx is equal to, let's take for this side, dt by dx minus 4. That is dy by dx. We have dy by dx is equal to this one. That means we call it as t. So this is t square. So dy by dx is t square. Now t square is equal to dt by dx minus 4. That is t square plus 4 is equal to dt by dx. Now t square plus 4 and dt are variables in t. So separate the variable. Let's take dx this side. Dx is equal to 1 by t square plus 4 dt. And now integrate. Integral dx is equal to integral 1 by t square plus 4 dt. Now this is integral dx is x and this is integral 1 by t square plus 4. This is integral t square plus 2 square. That is, we have the formula integral 1 by a square plus x square is, we have the formula integral 1 by a square plus x square dx is 1 by a tan inverse x by a plus c, constant. So this one is equal to x is equal to integral, here a is equal to 2. So we have x is equal to 1 by 2 tan inverse t by 2 plus c. That is the answer, and t is x is equal to 1 by 2 tan inverse 4x plus y plus 1 by 2 plus constant c, and we can take 2 here, that is, let it be c by 2. So 2x is equal to tan inverse 4x plus y plus 1 by 2 plus c. So 2x, let's take c here, 2x minus c equal to, so tan 2x minus c is equal to 4x plus y plus 1 by 2. So this is 4x plus y plus 1 equal to 2 tan 2x minus c. So this is y equal to 2 tan 2x minus c minus 4x minus 1. So this is the final answer. Now let's solve exercise 11.2. First question is y into root 1 minus x square dy plus x root 1 minus y square dx is equal to 0. So let's solve this. So this is the question. First we need to separate variables. So here y and x is there. here x and y. So let's separate y root 1 minus x square dy equal to minus x root 1 minus y square dx. This is equal to y root 1 minus x square dy equal to minus x root 1 minus y square dx. Take this function this side. So here y and dy is there. Now let's take 1 minus root 1 minus y square here. That means y divided by root 1 minus y square dy here. Now let's take this x term here. Minus x divided by root 1 minus x square dx. So now integrate y by root 1 minus y square dy equal to integral minus x by root 1 minus x square dx. So we need to integrate this function. This is the same function. Let's take 1 minus y square equal to t. Let's differentiate both sides. This is 0 minus 2y dy equal to dt. dy is equal to dt by minus 2. So y dy is equal to dt by minus 2. Let's substitute this value. Integral y dy is dt by minus 2 divided by square root of t. That means minus 1 by 2 integral 1 by root t dt. Root t is t raised to 1 by 2. So this is minus 1 by 2 t raised to minus 1 by 2 dt. T raised to 1 by 2 is root t. So taking upper, this is t raised to minus 1 by 2. Now integral of this is t raised to minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus integrating constant. Now this is minus 1 by 2 t raised to 1 by 2 by 1 by 2 plus constant. 1 by 2 cancel. This is minus root t plus c. So these two are both same integrals. So let's integrate both sides. The integral of this side is, integral of this is minus root t. Root t means 1 minus y square plus integrating constant which is equal to minus of, this is same integral, minus of root minus root 1 minus 3. So plus root 1 minus x square. Now this is root 1 minus x square plus root 1 minus y square equal to c. This is the solution. Now second question is, I'm solving 3. Sec square x tan y dx plus sec square y tan x dy equal to 0. So this is the question. Let's separate variables x and y. This is sec square x tan y dx plus equal to minus sec square y tan x dy. So let's separate x and y. This is sec square x dx. Take this tan x here divided by tan x, which is equal to minus sec square y divided by tan y dy. So let's integrate this, integral of this and integral of this. That means this is tan x and sec square x. This is derivative of tan x is sec square x. Put t is equal to tan x, or dt derivative is equal to tan x derivative is sec square x dx. So this is log tan x. Integral is log tan x. How this? If you substitute here, this is integral of dt by t, which is log t plus constant. So we can write it as log tan x equal to minus log tan y plus c. So this is log tan x plus log tan y equal to c. That means log a plus log b is log ab. Tan x into tan y equal to c. Let's take this c as log c. Log c also a constant. So this is log c. Log c also a constant. So log c. That means tan x into tan y is equal to c. So this is the solution. Now let's solve e raised to x tan y dx plus 1 minus e raised to x sec square y dy equal to 0. Now let's separate the variables. E raised to x tan y dx equal to 1 minus e raised to minus of 1 minus e raised to x sec square y dy. So e raised to x divided by 1 minus e raised to x dx equal to minus of sec square y divided by tan y dy. So let's integrate both sides. Integral of this equal to integral of this. Integrating this, we can relate this as this question. That means 1 minus, let's put t equal to 1 minus e raised to x. Dt is minus e raised to x dx. So this is also integral of t dx minus e raised to x dx is minus dt. So minus dt divided by 1 minus e raised to x is t. That is minus log t. Minus 1 by t dt is minus log t or log 1 by t. So we can write it as log minus log 1 minus e raised to x. So minus log 1 minus e raised to x plus constant c equal to, this is minus log tan y. So let's take log this side. Log tan y minus log 1 minus e raised to x is equal to c, constant c. So log a minus log b is log a by b, tan y divided by 1 minus a raised to x is equal to constant c. Let's take the constant as e raised to c. That means tan y divided by 1 minus e raised to x is e raised to c. When we remove log, this is e raised to c. E raised to c is another constant, let be c1. So tan y divided by 1 minus e raised to x is c1, or tan y is equal to c1 into 1 minus e raised to x. Y is equal to tan inverse of c1 into 1 minus e raised to x. So this is the solution. Now let's solve the next problem. X dy by dx is plus cot y equal to 0. So let's separate the variables. X into dy by dx equal to minus cot y. Now this is dy term. So let's take cot y this side. 1 by cot y dy is equal to minus 1 by x dx. Dx x 1 by x. So minus 1 by x dx. Now integrate both sides. We get 1 by cot y is Cot y is cos y by sin y. 1 by cot y is sin y by cos y. That means tan y. Sin y by cos y dy. Let's take this minus here. So as we can easily calculate. So take this minus here. So this is minus sin y by cos y dy, which is equal to 1 by x dx. So this is cos y derivative is minus sin y. So this is integral of this is log cos y. Cos y derivative is minus sin y. We have, if this is f dash x divided by f of x dx, integral of this is log f of x, as we see earlier. If you put t equal to f of x, dt is f dash x dx. So this is 1 by t dt, that means log. So this is log cos y and this is log x plus constant c. That means log cos y minus log x is equal to c, or we can take it as log c. Log c. So log a minus log b is log a by b. Cos y divided by x is log c. That means cos y divided by x is c, or cos y is equal to c into x. We can write it as cos y is equal to c into x, or y is equal to cos inverse cx. So this is the solution.